Voyager 1, a spacecraft no bigger than a compact car, is quietly drifting through the vast, unimaginable darkness of space, over 14.5 billion miles from Earth. Launched in 1977, it was only meant to last 5 years. Yet nearly 5 decades later, Voyager is still going strong, defying expectations. But recently, it's been acting strangely. It has begun transmitting signal patterns, pulses, and data that seem off. Could Voyager have encountered something unusual in the interstellar void? Or more unsettling, has something out there discovered Voyager? The story of Voyager doesn't start with rockets, but with a rare cosmic opportunity. In the early 1970s, astronomers realized that something extraordinary was about to happen. Jupiter, Saturn, Uranus, and Neptune would soon align in a way that only occurs once every 175 years. This rare configuration would allow a spacecraft to use each planet's gravity to slingshot to the next, making a grand tour of the outer solar system possible in a single mission. NASA couldn't pass up the chance. They began designing twin spacecraft capable of surviving Jupiter's harsh radiation, the unknown hazards around Saturn's rings, and a journey through the cold, uncharted reaches beyond. Thus, the Grand Tour mission was born, later renamed Voyager. The spacecraft were marvels of 1970s ingenuity. Each weighed about 1,800 pounds and carried 11 scientific instruments. Power came from radioisotope thermoelectric generators, RTGs, essentially nuclear batteries that convert the heat of decaying plutonium into electricity. Solar panels were useless, so far from the sun's reach. Building the Voyagers was a colossal engineering feat. Systems had to work flawlessly for years with no chance of repair. Engineers added multiple backups, and even programmed the computers to troubleshoot and fix issues on their own. Yet those computers had just 68 kilobytes of memory, less than what's needed to store a single digital photo today. On August 20th, 1977, Voyager 2 launched from Cape Canaveral. Despite its name, it went first. Then on September 5th, Voyager 1 followed, riding atop a Titan I rocket. Because it was on a faster path, Voyager 1 would overtake its twin, reaching Jupiter and Saturn first. As the twin probe sailed into the cosmos, no one could have imagined that nearly 50 years later, one of them would still be making headlines. Not for what it was discovering, but for what might have discovered it. Voyager 1's voyage through our solar system was nothing short of historic. After a journey of about 18 months, it reached Jupiter in March 1979, and what it saw changed everything. From Earth, Jupiter had always looked like a beautiful but simple striped sphere with a curious red spot. But through Voyager's lens, it became a planet of immense complexity. The Great Red Spot, seen for centuries, was revealed as a gigantic storm system large enough to swallow 3 Earths. The colorful bands were not just visual features, but powerful jet streams and massive tempests racing across the planet. But it was Jupiter's moons that truly stole the spotlight. Io, the innermost of the large moons, stunned scientists when Voyager captured active volcanic eruptions in real time, the first ever seen beyond Earth. These volcanoes spewed sulfur that coated Io's surface in hues of red, orange, and yellow, giving it the look of a cosmic pizza. Then there was Europa, a smooth, bright moon covered in cracks like a shattered eggshell. Voyager's images sparked a thrilling theory. Beneath Europa's icy crust might lie a vast ocean of liquid water. Later missions would support this idea, making Europa one of our top candidates for alien life in the solar system. From Jupiter, Voyager 1 continued on to Saturn, arriving in November 1980. Seen from Earth, Saturn had always appeared majestic, but simple. Up close, it was something else entirely. Its iconic rings, which looked like solid bands through telescopes, broke into countless thin ringlets, some braided, some with mysterious spokes, shifting and shimmering in a celestial dance. But it was Saturn's largest moon, Titan, that especially captivated scientists. Titan was the only moon in the solar system with a thick atmosphere, one that hinted at complex chemistry, and perhaps even prebiotic conditions. Voyager couldn't see through Titan's dense orange haze, but measured the moon's atmosphere and discovered it was primarily nitrogen, just like Earth's. This finding eventually paved the way for the Cassini-Huygens mission decades later, which revealed the presence of lakes and rivers of liquid methane on Titan's surface. After completing its mission at Saturn, NASA faced a choice for Voyager 1. Send it to Pluto, then still considered the ninth planet, or direct it northward out of the plane of the solar system to begin its journey into interstellar space. NASA chose the latter. Meanwhile, Voyager 2 continued on to Uranus and Neptune. As Voyager 1 left Saturn behind, it turned its camera back toward the solar system for one final glimpse. In February 1990, at the suggestion of Carl Sagan, it captured a series of photographs, including the now famous pale blue image. Earth is a tiny blue speck suspended in a sunbeam seen from 3.7 billion miles away. Sagan's reflection on that image became one of the most profound commentaries on humanity's place in the cosmos ever written. After that moment, Voyager 1's cameras were shut off to conserve power. Visually blind, the spacecraft continued its journey into the void, still sensing, still listening, still transmitting data from the space between the stars. Affixed to the side of each Voyager spacecraft is a 12-inch gold-plated copper disc, the Golden Record, a time capsule meant to tell the story of Earth to any intelligent life that might encounter it in the distant future. The story of the record is nearly as remarkable as the Voyagers themselves. NASA gave Carl Sagan and his team just 6 weeks to decide what should go on it. 6 weeks to encapsulate all of human civilization. They worked tirelessly, debating what sounds, images, and music should represent our planet to the universe. The final result was extraordinarily diverse. Greetings in 55 languages, from ancient Akkadian to modern Wu Chinese. Natural sounds like thunder, volcanoes, birdsong, whales, laughter, footsteps, and human heartbeat. Music from all over the world. Bach's Brandenburg Concerto, a Navajo night chant, a Peruvian wedding song, and Chuck Berry's Johnny B. Good. There are 116 images encoded in analog form, illustrating mathematics, DNA, human life, and Earth's landscapes. Also included are messages from President Jimmy Carter and UN Secretary-General Kurt Waldheim. Each record comes with a diagram showing how to play it at 16 2/3 RPM and a pulsar map pointing to Earth's location in the galaxy. The records are built to endure for billions of years, long after Earth is gone. Though the odds of an alien civilization ever finding one of the Voyagers are astronomically small, the nearest star along Voyager 1's path is AC plus 793888, which it will pass in about 40,000 years. It was never really about being found. As Sagan put it, the record is a symbolic gesture, a cosmic message in a bottle. We made it this far. We hope you exist. There's something deeply moving about those golden records still flying outward, carrying the laughter of children, the songs of whales, and the rhythm of Bach into the blackness. They represent humanity at its most hopeful, most visionary, the same spirit that launched the Voyagers in the first place. Little did we know, though, that the golden record might not be our first message to be received, because something, out there in the vast darkness, seems to have noticed Voyager itself. After it encounters with Jupiter and Saturn, Voyager 1 entered what engineers call the cruise phase, a quiet, seemingly endless journey through the outer solar system. With no more planets ahead, public interest faded. The stunning images stopped, and NASA turned its attention to newer missions like the Hubble Space Telescope and the Mars rovers. But Voyager kept going, traveling nearly 1 million miles every day, steadily approaching the edge of the solar system, wherever that boundary might be. At the time, even scientists didn't know for certain where our solar system ended. They only knew that the sun created a vast protective bubble, the heliosphere, powered by the solar wind. A stream of charged particles known as the solar wind flows outward from the sun, forming a vast bubble as it pushes against the interstellar medium. For decades, scientists didn't know the exact size of this bubble or what lay beyond it. During this quiet phase, Voyager 1 steadily transmitted critical data from the outer solar system. It observed how the solar wind changed with distance, charted magnetic field lines, and detected high-energy cosmic rays originating from beyond our solar neighborhood. These insights helped researchers refine models of how the sun interacts with interstellar space. Life aboard Voyager 1 during those years was a constant fight against time. Its power source, generated from the decay of plutonium-238, lost about 4 watts annually. Engineers faced difficult decisions, gradually shutting down instruments to conserve energy. The spacecraft's cameras were turned off in 1990, followed by other systems as the power supply dwindled. Meanwhile, Voyager's increasing distance from Earth made communication progressively more challenging. Its signal grew so faint that only NASA's largest deep space network antennas could detect it. By the 2000s, a single radio transmission took more than 14 hours to travel one way, even at the speed of light. Despite the challenges, Voyager 1 kept sending back data from a region no spacecraft had ever entered, the boundary between our solar system and interstellar space. In 2012, it crossed the heliopause, the outer edge of the sun's protective bubble, officially becoming the first human-made object to enter interstellar space. The environment beyond was strikingly different, filled with galactic cosmic rays and magnetic fields that bore little resemblance to those within the heliosphere. It was the beginning of a new chapter in space exploration. Yet, even in this uncharted territory, Voyager 1 began sending signals that puzzled scientists. These transmissions included unusual bursts and patterns that didn't align with any known spacecraft behavior or natural cosmic event. Engineers at NASA's Jet Propulsion Laboratory first suspected a technical malfunction, understandable given the spacecraft's advanced age and prolonged exposure to cosmic radiation. However, the signals didn't match any familiar electronic glitches or interference patterns. Some scientists proposed that Voyager might be detecting an unknown astrophysical phenomenon, perhaps previously unidentified interstellar particles or the distant signatures of pulsars. But others entertained a more extraordinary idea. Could Voyager 1 be receiving energy or messages from an alien source somewhere within the local interstellar medium? Though speculative, the notion that Voyager, humanity's most distant envoy, might serve as a receiver or beacon for extraterrestrial contact sparked global intrigue. All the while, Voyager 1 continued its solitary trek through the vast, silent void. It speeds outward at approximately 38,000 miles per hour through a near-perfect vacuum, where temperatures hover near absolute zero and cosmic radiation from distant stars fills the darkness. Currently, Voyager is passing through a region known as the Local Interstellar Cloud, a mysterious, slightly denser area of space. Almost 5 decades since its launch, Voyager 1 still sends faint whispers back to Earth. Its enduring mission reminds us that the spirit of exploration lives on, reaching ever farther into the unknown.